Hello and welcome to my channel Code with GD. In this video, I will be designing a URL shortening service, something like TinyURL. You all must have used something like TinyURL or bit.ly. This is a classic and interesting system design problem. Let's understand the problem statement in a better way. So assume that you are given a very long URL, for example, and you need to convert it to a shorter URL, something like. So my problem statement now is whenever you are given a long URL, convert it to a shorter URL. Once someone is on the internet and is typing the short URL, it should redirect the web page to the longer URL. So I will note down the two use cases, redirect and shorten the URL. So before diving deep into solving this problem statement, we should also have an idea of the scale at which the system will work on. This will play a crucial role in deciding how short we can make the URL. So my problem statement is make the URL as short as possible. For that we need to know the scale. For the purpose of this video, let me assume that I work at a scale of 100 million URLs. Like I will need to generate 100 million short URLs per day. And regarding storage, I need to store the URLs of the last 10 years. So my system should be designed so that it works for the next 10 years. Regarding storage or the number of records I need to store, from these above two, I have 100 million URLs generated per day into 365 days in a year, and it should go for 10 years, which means I have to store 365 billion records. So this calculation will come in handy when we design our system. So let's start at designing our system. First, let's look at the easier part, that is API design. Based on the requirements, we will need two APIs. So the first requirement is shorten the URL. For this, we can create a post request, and that can look something like slash API slash shorten, and it can have a request body that will have the longer URL, and the response can be the shorter URL. So this is with the first API. The second is to get the longer URL from the shorter URL. In this case, we actually need to redirect the short URL to the longer URL, and this will be a get request, and it will be the shorter URL, something like https short URL slash some random text. Now the way to do redirection is the server can return either a 301 status code or a 302 status code with the longer URL in response. It will be in the header only. The way the architecture would work is we have a client machine, which is essentially your computer, and the short URL server will be something like this here, and this longer URL is of, let's say, Amazon, and the Amazon servers will be in a different location. Now this client user or your laptop will hit the short URL, and this shorter URL will return a response with a response code of either 301 or 302 with the longer URL in the response. This client will then get the longer URL, which will be of Amazon, and it will hit the Amazon server to open the page. So this is how redirection works. Now there is a difference between both of these response codes. 301 is something of permanent in nature. So if the response code is 301, it tells the client that this mapping is permanent, like this short URL is permanently direct to the Amazon servers, and the 302 response code indicates the mapping is temporary in nature. If your system returns a 301 response code, the client will store the mapping in its local cache because it knows that the mapping is permanent, and this shorter URL will always redirect to, let's say, the Amazon server in this case. So next time the local machine has to call this shorter URL, it will not call the shorter URL server, but it will directly call the Amazon URL because it has set the value in the cache and it will call the server. Whereas in temporary, no such cache is stored in the local machine. So every time this URL is called, the machine will go to the short URL server, get the longer URL, and then hit that URL. So the difference is, the pros of this is it is faster. Like the subsequent requests are faster. The first one will still be slow because the local machine needs to know which URL it is calling. And the, the advantage of having this is you can actually track how many times this shorter URL has been used. So for example, you are charging your client on per click basis. So you can know that okay, the client has used this URL, let's say 10,000 times. So you can charge the client on that. So in that case, C02 is better. Whereas if you don't have any such requirement and you need your service to be faster, use a 301 redirection. So now let's move to a more interesting part, that is the URL shortening approach. The most intuitive way to store long URL and short URL mappings is in the form of something like key value pairs. So you can have the short URL as the key and it will be mapped to a longer URL. So whenever a short URL is queried, you search in the hash table using short URL as the key and get the longer URL in return, to which you need to direct your web page. And for URL shortening, the URL can look something like, as discussed before, HTTPS and then the domain. I'm taking short.url as example for now, and then some random bits. Now for each short URL, the set of random bits can be different. So the flowchart would look something like this. So you get a longer URL and then you pass it through a hash function. The hash is generated and you append it as the random bytes after the short.url, and corresponding to this short.url we store this longer URL. So this is like the basic design that I am planning to implement, and this looks good also. There are a couple of black boxes here. One is where do we store this mapping, and the second is how would this hash function look like. And well, there is a third one also, like we need to keep this URL as short as possible. Now this first part is something that cannot be changed. This is fixed. So we need to make this random bytes as short as possible. So how do we do that? So that is also something that has to be derived from the output of this hash function. So yeah, let's look at each of these. So coming to the first point, how to store the hash table, which is my key value pair. Well, we can use a relational database for it. So we can have something like ID, which is the primary key, and then we can have the key, which will be a shorter URL, and then we can have the longer URL. We can't have everything in memory because we need to persist the data, and we calculated at the beginning like we will have close to 365 billion records, so we need to use a proper database for it. Now let's look at the hash function, like how it would work. So we discussed we need to like minimize the output of this hash function as small as possible because that would decide the length of my tiny URL. For this, let's calculate how many bits will be required. So for that, let us decide how many characters are required that can store 365 billion records without any collisions. Now the hash function output can contain alphabets like A to Z. We can also have capital A to Z or numbers 0 to 9. For now I will limit this between these only. So A to Z is a range of 26 characters. This is also a range of 26 characters, and 0 to 9 is like 10 characters, which adds up to 62. So now the question is, using 62 characters, how many blank spaces you need to fill 365 billion records. So if we had one space, we can have 62 different variations. If we have two spaces, we have 62 into 62 variations, which is essentially 62 to the power 2. Similarly, for three spaces, we have 62 to the power 3 number of variations we can accommodate. So essentially, we have to find a number n such that 62 to the power n is greater than 365 billion records. Upon calculation, you can find that 62 to the power 7 is equal to 3.6 trillion, which is obviously more than this. So my hash function output should be like within 7 characters. To put it simply, using just 7 blank spaces and 62 characters, like the combination of both of these can give me 3.5 trillion records, which is like more than enough to store the 365 billion records I wanted to store. So yeah, this will be my shorter URL length. Like it won't exceed this the domain plus 7 characters. Now the next black box is how does the hash function work? Now there are a couple of ways to do it. First is there are standard algorithms like SHA or CRC32 or MD5 that generate hashes. Like you can give any number as input and they will generate a hash result. The problem with this is this hash, the length of this is not 7, it is like a random length which is different for each of these hashing algorithms. Now you know that these hashing algorithms will uniquely generate the output, but we need to limit our range to 7 characters. Now you might think that okay, so what's the problem? Take these hashing algorithms, now give the longer URL as input. You will receive a unique set of characters, let's say random XYZ ABC123 4, and then truncate the first 7 characters. But the problem is the first 7 characters can be common, like the entire output is different for the longer URLs, but there can be a collision, like two different long URLs can have the same first 7 characters but different remaining characters. So using this is not a good approach because we will have collision, and then again we have to have a collision prevention system in place. So it will make things more complicated. We can definitely have it, but we don't want to increase complication in our system. So yeah, we will not go with this method. The next approach is something called base 62 conversion. This works in a similar way in which you convert one number system to another. For example, if you want to convert a number, say 23, to decimal number system, which is a base 2 conversion, you keep on dividing 23 by 2 and store the remainder, and then you get this number as the decimal number. Is this correct? Yeah, so this adds up to 23. So the reason I selected base 62 is because we have 62 different characters we can fill. So in binary we had 0 and 1 as the only two characters we could use, but now we have 62, so I am calling it base 62 number system. So in this you can assume some kind of encoding, like we use numbers 0 to 9, small a to z, capital A to z. You can assign numbers like 0 to 9 can be 0 to 9, then A to Z can be from A till I don't know 36, and then this capital A can be then 37 to I don't know 61 maybe. So I will take a very common example. I will take an example from the book I was reading. For example, I have 11157, and I want to use the same way. I want to use the same remainder technique that we used in binary. So I will divide it by 62, and the remainder is 59. Similarly, if I again divide it by 62, 62 into 2 is 124, and the remainder is 55. So 255 and 59 is the encoding, and on converting it using this system, we get, so 2 will be 2, 61 is z, so 59 will be x, and 55 will be t. So I converted this 1157 to 2tx in the base 62 conversion. So this is how we will design these hashes. So the final URL, shorter URL, will look something like short.url/2tx. Now you will be having one question, like we want to give input as a URL which is a string. So my input is a string, but how is converting a number to this helping? So for that we will have to use a separate unique ID generator. So you remember in the hash table which we saw, we had an ID field, a short URL and a long URL. So this ID can be a number, and this ID will go as input for this base 62 conversion. We have an ID, we have a long URL, and we have a short URL. First ID was, let's say, 1, and assume it to be a bigger number, 231, 1, 1. And the next ID will be 12312, and at this point when random long URL comes as our input, the system will then look at the next available ID, that is 12312. It will pass that to through this base 62 encoding. Since we are encoding this to a smaller or a different number, we will get 3 random or up to 7 random words. Up to 7 because we did our calculation, and after that we get the shorter URL. So this is how this ID is taken as an input to our base 62 conversion. Here the obvious question would be, if this is the case, someone can always predict what the next short URL will be, because these IDs are generally sequential in nature. To prevent that, we can use a different service, that is unique ID generator. How this works is a completely different topic for system design. I will cover that topic in the next video probably. The link will be in the I button at the top. Anyways, for now you can assume that this unique ID generator will generate random IDs uniquely, and which can be taken as input to the base 62 converter, and we can get the shorter URL. The main advantage of using a base 62 converter and a unique ID generator, the combination of both these, is that we will have no collisions in the generated shorter URL. And that's it with the system design of TinyURL generator. Some extra things we could do is we could add a rate limiter in our system. So you could put a limit on the number of times a particular short URL is used to redirect, or you could also charge your clients based on the number of times they are using the shorter URL. Uh, the other point is, since whole of the system is stateless, that means any request does not depend on the input of the previous request or how the previous client interacted. We could use something called auto scaling on this system. Auto scaling means if more and more people are using your system, it will automatically increase the number of servers to serve the request of the people. And similarly, it will kill instances if the number of people using your system goes down. Now, if you use rate limits, you can also perform analytics on your system to know more about the type of people or the type of clients using your system. So yeah, these are some of the techniques or add-ons which you can add to your system to make it more robust and scalable. Yeah, so that's it for this video. If you liked it, don't forget to subscribe to my channel Code with GT, and share this video with your friends if you found it useful. Thank you for watching till the end. Bye bye. Happy coding.